Oh my goodness, you guys. I was muted that whole time. Didn't you see me talking to you? All right. So yesterday, what I said was yesterday we started off, we were talking about the product rule, the quotient rule, and the power rule. And so for the first one, my question was, what do we do first? What's the first thing we should do here? How about Lauren? Can you guys hear me now?
Yeah, we can hear you.
Yeah, we can hear you.
Okay. So Lauren, if you're there, what should I do first on number one? All right. How about Kyler?
First, you would separate them. Since it's the division, you'd subtract them. So I had log base 8 in parentheses x minus 1 to the power of 3 over 2 minus log base 8 in parentheses a squared to the power of 3 over 2.
Okay. Oh, sorry, Lauren. Okay, so that's the second step. The first thing you want to do is take care of this exponent. That the exponents, when you're expanding them out, you move the exponents down first. So it's going to be 3/2 times log of this. Okay. So you just want to bring that exponent down first. And then what you said, the next step is right. We're going to take care of that division and separate it out. So this is going to be 3/2 times the quantity log base 8 of x minus 1 minus log base 8 of a squared. Now I do see that we have another exponent in there. So now that I've kind of unpacked that a little bit and pulled it apart, now I can bring that other exponent down. So this would be 3/2 times log base 8 of x minus 1 minus 2 times log base 8 of a. Okay. Now we could simplify just one more step by distributing that 3/2 if we wanted to. So I could do something like this. So this will be 3/2 log base 8 of x minus 1 minus, now what's 3/2 times 2? That's just 3. So the reason this is nice is it kind of simplifies a little bit. And that would be the most expanded you can go. Can I do anything with that x minus 1 in there? The answer is no. We don't know anything about subtraction or addition inside of the log input. Okay. It's just if you have multiplication and division in there, then you can pull it apart. But if you have addition and subtraction in there, there's nothing you can do. You just leave it. Any questions on this? Okay. Now the second one, I did throw in a little wrench here because I have 3 operations. And the truth is it won't really matter. I would just work left to right. Okay. We're going to first pull up all our exponents. All the exponents should go first. Okay. So it's the opposite order. The first move in the expanded form is to bring the exponent down. The first thing we want to do here to condense it is bring it up. Okay. So this is going to be log base 2 of x to the 1/2 plus log base 2 of y cubed minus log base 2 of z to the 5th. Okay. Now we're going to bring these two together. Now I have addition between 2 logs. So how can I bring those inputs together? What
Multiply them.
Multiply them. Good. And you know what? Just because you can leave this as x to the 1/2, or if you write it as square root of x, either way is fine. And then I have minus log base 2 of z to the 5th. And then the last thing is to pull these together into division. So this is log base 2 of, just to show you the other way, we could write y cubed square root x over z to the 5th. Okay, so that would be the way to bring that together into one. Any questions on those? Okay, I want to pick back up where we left off yesterday with those estimating the decimals. I do want to say though about the quiz, I started grading them yesterday. All the people that were able to upload it properly, I was able to finish. And then there's other people that had to send it to me in an email because Canvas wasn't allowing people to attach stuff. I still have to do yours. I have to switch to my laptop. I don't know if I can pull them up on my iPad. I don't know. This grading online thing is slow going sometimes. So, but what I'm noticing is that people are not, you guys are still not totally with it on the sign charts. You have to learn to do a sign chart. So there are problems in which people did stuff and they got the right answer, but they did not do a sign chart, or even checking their regions for true or false didn't show all the work. You have to it's almost like a proof. You need to show me all the way to the end how exactly you can get this. So if you don't do a sign chart, you automatically lose points. And that's the way the final is graded too. So you have to do the sign chart. You have to learn how to do it. There's no avoiding it. So come to office hours if you're one of those people that's still not sure how to do that, 11:30 today. And you're going to have to use those again in 1800 and Calc 1. Like making a sign chart is going to come up again and again and again. You got to know how to do it. So yeah. Procrastinating or putting that off is not going to help you. All right. That's my little mini lecture for today. The lecture within the lecture. All right. So yesterday we started doing these where you estimate. So let's do an example. So using the approximate values log base 7 of 6, say that's 0.9, and that is an estimate, but I'm just saying it's 0.9, and then log base 7 of 18 is 1.5. We want to find so here's A, log base 7 of 3, B, log base 7 of square root of 42, and then C is log base 7 of 1 over 36. Okay. You cannot change what's inside the function. So note, let me put this note. We can only rewrite 3 square root of 42 and 1 over 36 using properties or arithmetic. Okay, so let's do that. Now the first one, how can I use 6 and 18 to get 3? Because 3 is not given to me. And I can't break it apart at all. Log base 7 of 3, there's no exponent. 3 times 1 is 3. There's nothing I can do with that. But
you can rewrite it as 18 over 3. 18 over 6.
Yes, very good.
Yeah.
We're going to rewrite it. And this is just arithmetic. This is what I'm saying. This isn't a property necessarily. 3 is 18 over 6. I'm just using the information I'm given so I can use those equivalences, those numbers. So now that I have it as a fraction, we can break it apart using our quotient rule. And now I can use the numbers they're giving me. So this is 1.5 minus 0.9, which is 0.6. Like 15 minus 9 is 6. So 1.5 minus 0.9 is 0.6. Now, I will say this. Some students, you guys, especially the ones that are quick, they jump from here to here. And they skip all that showing the work part. I will tell you this. If you do that and your decimal is wrong, I have nowhere to give you partial credit because I don't know what you did to get that decimal. If you don't show me what property you're using, I can't give you partial credit. And in fact, I think in the rubric, the grading rubric, we're supposed to take off points for that. So you have to at least show me this step so I see what you're doing and why. Okay. So word to the wise. Okay. Warning over. All right. So let me just write that, show all steps. Okay. Now the next one, yeah, but I think Marianne, and I was looking at what you emailed me yesterday. I didn't get to respond. I think you're just doing extra steps there. But I'll look at that in a minute. Let me keep going here. All right, log base 7 of 42. Log base 7. Now, the only thing, this 42, 18 is not a factor of 42. It's not like I can write 18 times something to give me 42. So I'm going to have to use, 6 and 7, exactly. So this is going to be 6 times 7, and I'm going to write the root as a power, okay? Write that as a power. And now we can use our power rule, bring that down in front, and that's 1/2 log base 7 of 6 times 7. And then I can break it apart into 1/2 times the quantity, log base 7 of 6 plus log base 7 of 7. Okay. Now, this is going to be a direct input, like I'm going to directly substitute in for log base 7 of 6. I know this is 0.9. But what about log base 7 of 7? What is that?
1.
Yeah, good. 1. So anytime you can get that where the base is the same, you're going to get 1. So this is going to be 1/2 times 1.9. And what we could do is write this as 0.5 times 1.9, because 1/2 is 0.5. And on this, I am going to have to do a little bit of work here. So this is 45. 5 times 1 is 5 plus 4 is 9, 2 decimal places. So this is 0.95. Any questions there on the first two? Okay. Now, for part C, how can we rewrite 1/36? Have a 6. This is 6 to the power of -2, right? 1/36 is 1/6 squared, which is 6 to the -2. Okay. Now we bring down the exponent, -2 times log base 7 of 6. That's information I know. And this is -2 times 9 is 18, and it'll be 1 decimal place. questions? That would be the easiest way to do that. We could have done this a different way. Actually, let's look at C, because I just want to show you that there is another way to go about this. What else could we have done with 1 over 36? Anybody have a different thought process?
I initially I did log base 7 of 1, and I was going to subtract log base 7 of 36,
Yes.
which broke down, but yeah.
Very good. Okay. So this also works because what is log base 7 of 1?
Oh.
0. 7 to the 0 power is 1. And then this is going to be log base 7 of 6 squared. So we get 0 minus, which is just basically minus, right? This is minus 2 times log base 7 of 6. And then we get to the same place, negative 2 times 0.9, which is negative 1.8. So there's a different way you could have done it right there. So sometimes you have options. I don't think the square root of 42, I'm not sure we could have done that any differently. It would have been a lot more convoluted, unnecessarily so. But I say for part C, either one of these is perfectly fine. Straightforward, no issues. Any questions? Were these on your homework at all last night, on the online homework?
Yes, it was.
Kind of, a little
There
bit?
was some problems at the end.
Okay.
Like only 2 of them.
Okay. All right. Good. There's going to be definitely some on the hand-in homework due Wednesday. Okay. This is a problem that comes up in the final exam every year. So you got to know how to do these. And it looks easy when we're doing it together in class, but when you sit down to do it, you're going to get thrown for a minute. Just don't give up. Okay. Keep trying stuff. And remember, use properties. Don't just like, you got to look for using these kinds of rules. Okay. All right. Now 9.5 is a very simple section. It's a little section about the natural log. So I don't even know if I wrote down notes on this. Just wanted to say a couple words about it because we're not going to talk about it too much because it's the same thing as log. I'm not doing anything incredibly different. I don't think I have anything. Okay. So the natural logarithm is it's a logarithm with a special base. And what it is this log base e of x. And this is special because e is like pi. So you guys may not, I don't know, some of you may know, but this is about 2.71. But this is an irrational number, similar to pi, where the decimal form goes on forever and never repeats. Okay. And if you studied it, it has, if you were to look into it, the whole mathematics behind it has to do with something called the golden ratio, which we're not going to go into. But what we do is when we have log base e, we write it as ln of x. This is the notation. Okay, so if you see ln of x, it's just log. We call it natural log. And it has base e all the time. That never changes. Like you would never see this. Okay, this does not exist. No. All right, it's always natural log of x, and its equivalent statement, if I say natural log of x is equal to a number, this is saying e to the power of y equals x. Okay. All the same rules that we've been using or would apply. We would still solve things the same way. Now we use natural log. Sometimes some of you may know how to do like change of base and stuff like that. We use natural log for that. That's more like pre-calc, so we're not going to do that here. But this is all. I just want you guys to be familiar with this notation. Because once you get up into pre-calc and calculus, you basically only do natural log. You don't even, to see log base 5 of something, it's all natural log base e, okay? All right, so we're gonna go on to 9.6. And 9.6 is solving more log equations, but using these properties, okay? We have a little bit more power now than we had before. So, solving log equations. Okay, so to solve, yeah, to solve a log equation, one, move all of the logs to one side of the equal sign. And condense into a single logarithm expression. And just move every non-log term to the other side. Okay, so basically we're isolating log on one side of the equal sign and anything else goes on the other side. All right, the second thing is once you have a single log expression, we're going to use the definition of logs to get rid of the log. Okay, and then the third is if you use a log property to condense, you must check your answers. I know, our favorite thing, right? Okay. So let's do an example. Solve log base 10 of x. I wonder why, yeah. Plus log base 10 of x minus 3 is equal to 1. Okay. So I'm kind of starting you off here with an equation that has logs already on one side, okay? If you look at this, every term with log in it is already on one side of the equal sign. So we actually don't have to move anything. But now I'm in a position I can use my property to bring these together. So how can I bring these together into one? Which property is it?
Multiplication.
Yeah, the product one. So I'm going to multiply these together. So x times x minus 3. Now, once you have it in one log, you can use the property, which means that this 1 is the exponent you put on 10. So 10 to the first is equal to the stuff inside. So x times x minus 3. That's what I mean by getting rid of the log. You cannot solve it until you do this. If you try solving it with log as part of it, you'll either get something wrong or make some kind of actual error. Okay, so now we just have a quadratic. So this is 10 is equal to x squared minus 3x. Subtract 10 from both sides. And you get x squared minus 3x minus 10 is equal to 0. Okay. Factoring it, you get x minus 5, x plus 2 is equal to 0. And then x, whoops, jumped. X minus 5 is equal to 0, x plus 2 is equal to 0. So x is 5 and x is negative 2. All right, so since we use a property, we must check. Do the check. Okay, so how do I do that? I'm going to plug it into my original equation. So log base 10. So first x is 5. So log base 10 of 5 plus log base 10 of 5 minus 3 is equal to 1. And really what you're looking for here is you're just checking your domain. Okay, I can do this all the way out and you will get something true. Okay, log base 10 of 5 and log base 10 of 2. This is going to be log base 10 of 10, which is 1. Okay, but what I'm most concerned about is this is no domain issues. That's what you're really looking for. What is the domain restriction for log functions? What do I have to know?
Isn't it that it has to be greater than 0?
Yes, that's right. So if you have log of x, x has to be greater than 0. You cannot plug 0 or negative numbers into a log function. Okay, so this is good. So this is good. I have positive inputs, we're good. Now let's look at the other one. Let's check x is equal to negative 2. This is log base 10 of negative 2 plus log base 10 of negative 2 minus 3 is equal to 1. And you see really quickly, I end up getting, I mean, really, it's dead in the water right there. Okay, as soon as we plug in negative 2, I'm breaking domain. So this is not possible. This is not real. So we throw this solution out. You cannot include it. Any questions? So a little like just another example of why must we check? Well, because the properties can produce solutions that contradict the domain restrictions. Okay, there's the big fancy why. Okay, So let's look at a very simple example using numbers. If I have log base 8 of -2, and I add log base 8 of -4, okay? These two numbers are not real, okay? These are not real. Okay, but look what happens if I use my property. I can bring these together and I have -2 times -4, and I get log base 8 of 8, which is just 1. So this is false, okay? I can't add two not real numbers and get a real number. This is not possible. So that's why you have to be careful with those properties. Even though they're very useful in solving the equation, they can also give us bad answers. Is everybody, any questions on that? I want you to believe me. Have I adequately explained myself so you believe me that you have to check your answers? Okay, all right. Okay, so here, let's try this one. Log base 2 of x plus 1 equals 5 minus log base 2 of x plus 7. We're mad on time. Okay, we're doing good. Yeah. All right. All right, so when you guys do this one, what should we do first? What's the first move?
Get log base 2 of x plus 7 on the other side of the equal sign.
Beautifully said, Nija. Beautifully said. Okay, I got to get the same log expressions. I got to get them both on one side. And since that 5 is not a log expression, I want to leave it there. So let's add log base 2 of x plus 7 to both sides. And then I'm just going to write this out. Log base 2 of x plus 1 plus log base 2 of x plus 7. Now they're on the same side. Now we're cooking, okay? Next step is to condense, okay? You have to do this. You have to do this. We're going to condense this into log base 2 of x plus 1 times x plus 7 equal to 5. Now here's where a lot of students will make mistakes. They forget how to apply the definition, and they either just drop the log or they write something that doesn't make sense. But you have to use the exponential version of this. So this is 2 base 2 power is 5 is equal to the stuff inside of log. So this is x plus 1 times x plus 7. So must use log definition. I would say this is the part where a lot of students make the most mistakes because they jump. They try to jump from here to here. Not suggested, folks. I do not suggest that. So 32 is equal to, now we got to multiply this out, x squared plus 7x plus x plus 7, which is x squared plus 8x plus 7. And now it's just a quadratic. So I have x squared plus 8x minus 25, yes, equal to 0. Is that 25? Yes, okay. Ooh, I don't like that. Did I write something down wrong? Oh, I did. We would need quadratic formula for this. because this doesn't factor. It was supposed to be x plus 11. So can you guys just go back there and write in another one? So my numbers work out. Sorry. Only had 1 cup of coffee today. So this is going to be 77, and 77 minus 32 is plus 45, which does factor. And this is also 11x. So this is 18x. All right, so the quadratic, let me just go back to this step right here. So you're not just like, what? All right, when we multiply this out, it became 7x and 11x, and 7x and 11x is 18x. Are you guys with me? Is this okay? And then I'm going to subtract 32 from both sides, and I get x squared plus 18x plus 45 equals 0. And now this factors into x plus 15 and x plus 3. So x plus 15 equals 0, x plus 3 equals 0, and x is negative 15 and x is negative 3. Now, you might be thinking like, oh, they're negatives. We can't have negatives in log. That's not quite true. It's not just plugging in negative 15 and negative 3 because you have that x plus 11 and x plus 7. So when we check these, and I go back to my original equation, should be log base 2 of x plus 11 equals 5 minus log base 2 of x plus 7, right? Isn't that my original? Yeah. Now when you plug this in, you see negative 15 plus 11. That's going to give me a negative. So this is a no. But on negative 3, when I plug this in, log base 2 of negative 3 plus 11, that's okay. It's going to be positive 8. 5 minus log base 2 of negative 3 plus 7, that's okay. I get log base 2 of 8 equals 5 minus log base 2 of 4. Those are fine. This is good. Okay, no domain issues. So that's good. You can box it in. Any questions? All right, let me give you guys one. Let's do one with 3 logs in it. I don't want to mess around. I got to get a good one in here. I only got 5 more minutes with you guys. All right, so let's solve this one. Log base 7 of x plus 1 plus log base 7 of x minus 1 equals log base 7 of 8. Yeah, this is a good one. All right. Now, everything in my equation is a log term. Every term has log in it, but the rules are the same. I still need them all to be on one side of the equal sign, okay? So I'm going to subtract log base 7 x plus 1 stays, plus log base 7 of x minus 1 stays, and I'm going to subtract this log base 7 of 8 to the other side, which is going to give me a big fat 0 on the right side, okay? That's okay, don't freak out. Equations can be equal to 0. All right, now let's condense our logs, okay? And remember, in the warm-up, I don't know if you guys remember, but I gave you one kind of like this, a plus and a minus. Just go left to right. So this is log base 7 of x plus 1 times x minus 1 minus log base 7 of 8 equals 0. And now we can bring that one together as a quotient. Log base 7 of x plus 1 times x minus 1 over 8 equals 0. So we have 1 log. Okay. Now we use the definition. This is the power. 0 is the power that goes on base 7 that will give you what's inside. So you can do this. 7 to the power of 0, that's a number we know, right? What's 7 to the power of 0?
1.
1, yes. So this is just 1 equal to, and I hope you guys, this is a difference of squares, so it's x squared minus 1. I'm just going to multiply that out in my head. Okay. Multiply both sides by 8. And we get 8 is equal to x squared minus 1. And then you have two choices. You can add 1, and we get x squared equals 9, which at this stage in the game, we know that is plus or minus 3. Okay, if you take the square root of both sides, it's plus or minus 3. So negative 3 squared is 9, and also 3 squared is 9. And so, yeah, we have to check. I see you guys putting in the check. And you can look, if you plug in negative 3, we're going to get log base 7 of negative 3 plus 1. That's already bad news. Okay, so just plugging it in even to just this, you guys see where I pulled this from, right? Like here. Okay, in our equation, if I plug in negative 3, I'm going to get a negative. So it's no good. Now, if I plug in a positive 3, that's 3 plus 1 is 4. 3 minus 1 is 2. So that's fine. So if x equals positive 3, I get log base 7 of 3 plus 1 plus log base 7 of 3 minus 1 plus whatever. And then this is positive. Okay. So x equals 3. That would be the only answer you box in. And you must check every single time. Okay, any questions? All right, tomorrow we do our section from chapter 10. And that's all. All right, I will stay here. We have a couple minutes. If you want to stay and ask questions, I will stay. If you need to, come to office hours. Please don't make me chase you. I will see you tomorrow. Bye.
Thank you.